Good evening, everyone. Okay, as usual, we will start in a couple of minutes. Okay. Today we will quickly talk about task number 5. Well, but nothing new. Actually, this is why I don't have any presentation or something like this. So it will be pretty simple. So take your time if you still have something to do about the recent tasks. So go ahead. And if we'll talk about this one, it will be mostly about everything we already know. So we will try to deploy in our, okay, it will be a new application. So we will take this one. We will take this application, create a Helm chart for it, and deploy it in our Kubernetes cluster. So today we'll briefly walk through task number 5, and you will have a chance to answer your questions. And this is probably so. Let me please know if my screen is visible and if you can hear me well. And let's get started. Okay. If you're talking about, answering your question. So if you're talking about the Kubernetes cluster which is deployed in AWS, so I think it's better to stick to Elastic Container Service. And AWS also provides you with container registry, so you can leverage it to deploy your application inside of this cluster. But if not, you can always for sure deploy it in the public registry. So you can create a Docker account on Docker Hub and push your image right to it. But if I'm talking about the Minikube, it's a bit more simple. So you'll be already provided with the local registry, and you can store your image locally, and it will be just enough to deploy it in your Minikube cluster. Okay, so let's have a look at the task. So first of all, we'll need to create a Helm chart. We already have this application, and it's stored in the repository. So you will have a link in the task description. And this is a simple Python application running Flask. So it will just give you hello world, and this is probably it. So you'll run a web server, and this will be running your Kubernetes cluster, and it should be accessible from your local browser. If you're talking about the external deployments, so deployments on virtual machines, so you will also need to take care about the accessibility of your application. If you are running your Kubernetes cluster in private network, so you will need to once again create a reverse proxy for to make your application accessible from your local machine. If you're talking about Helm chart creation, I'm not sure if we already covered this topic on the previous task, so let's have a look. We have something about it. Okay, we're only installing it and setting it all up. So, okay, so I believe if we will try to find something, create Helm chart. So you may easily find the documentation about how to create it. You already have Helm installed, so it's as easy as running Helm create. You'll be provided with all of the necessary files to create your own Helm chart. Inside of this Helm chart, you will need to specify all of the values, all of the images which will be used by during this deployment. And you will have a chance to create your application the same as you deployed Nginx ingress controller in the previous one. So by running Helm install. once you're done with the Helm chart creation, you will need to deploy your application using Helm chart for sure. Ensure the application is accessible from the web browser, and store the application in Helm chart in your Git repository. So you will need just to, I believe, just to copy this simple application, the requirements, mirror not much of them, and store it in your local repository. So the same as it presented in here. You can avoid using README, for example. And once everything is done, so don't forget to document what have you done and how to use it. So you need to specify kind of small neat instruction about how to deploy this application using Helm chart. And this is it. So as simple as that. I think this week will be quite easy, at least relatively easy to the previous one. And what should be submitted? You need to create, once again, a new branch, which should be called task number 5 from your main one. Provide a pull request with all of the code. So it should contain your Helm chart, your Docker file, just to build your just to build your Docker image, and the application itself. Yeah, just to make it a bit more convenient for you just to deploy it. And provide a screenshot from your browser of a working application. There will be nothing more than just a blank screen and hello world on it. We're no magic. And provide README file documenting the application setup and deployment process. So this is the same as with the previous tasks, so nothing new. And about the evaluation, so if you can see the Helm chart itself in the repository, it's plus 40 points, 50 more for if this application is deployed using the Helm chart and application is accessible from the web browser. If you're talking about the minikube clusters, so yeah, it should be a screenshot proving what is really deployed. If it's in an external cluster, so feel free to share the link because it will be kind of cool and a bit more easier than putting the screenshot inside the fill pull request. And plus 10 points just for documentation. This is it. So, okay. So in the references, we have the same link on how to create your Helm chart. Any questions? I believe it's kind of quick one, just because we're nothing new, and this task is aimed just for you to understand how Helm works and how can you create your own Helm chart. And in the next one, we will try to automate the whole SDLC process. So we will have in our application, we will try to build it, we will try to push it and deploy it in our Kubernetes cluster. And as far as I remember, we would also make some tests for this application. Yeah, the SSLR cube and unit test. I don't know how to use, how to implement unit testing for this web page, but still. Okay. Yeah, as I already mentioned, it is kind of a quick one. So I'd suggest you to take your time and read about Helm, because I think it's the most popular way to deploy something in Kubernetes. So on the interview, you will be probably asked on how to use Helm, what is Helm, what are the advantages of Helm. So all of it is worth reading, worth testing, just to understand how everything of it works. Yeah, just maybe a quick note. So we don't need to automate everything right now. We'll automate it in the next task. So right now you need just to deploy all of it manually. But if you're brave enough, you can go ahead to the next task and try to deploy it via the Jenkins. So creating the pipeline, testing our application, deploy our application, and build this application, build an image for this application, and push it to the registry. Any more questions? Can we disable our Terraform CI workflow on PRs now, but they moved away from Terraform? I'd say yes. So we will not work with Terraform anymore, I believe. Maybe let's have a look at the last task about the monitoring. So will you have something on it? But I'm not sure. So probably not. CPU utilization, yeah, it will be kind of huge one. Yeah, so actually you can just step down from GitHub Actions. I will not use it anymore just because we have Jenkins right now. So yeah, you can turn off these pipelines by just removing them, or just setting the trigger to something else. So for example, by running it up manually, for example. Okay then. So next time in a week, we will talk about the CI/CD process once again. We'll try to understand how the proper pipeline should be implemented, just to cover all of the SDLC best practices. But currently, yeah, so this is it. If you will have any more questions, feel free to ask them in the Discord channel or ping me directly if you have some concerns or some issues with cross-check or with task itself. And see you in a week. Have a good rest of the day. Bye.